natural disasters, we need high availability systems in place. So for making high availability, for Oracle, for example, you have real application clusters. Of course, people are they are most of the BFSI verticals. They are using Oracle Exadata built-in high availability. So in Postgres, they have a replica, read replica. So each and every RDBMS, they have to protect for from common causes of IT disasters like power outages. So in MySQL, how we can leverage the high availability and disaster recovery using InnoDB cluster. So this is a basic replication topology of MySQL. Left-hand side we have source database, and right-hand side we have a replica. Normally we will say not physical standby like in Oracle. We will say here a replica. So in the source database, when the transactions are going on, your binary log file will be replicating, or no, it will go to the replica side, and your IO threads get the data. Then SQL thread, it will keep on applies the data into the replica database. Of course, you have binary log format. We can set it in the configuration file. How you can make utilize of replication topology, and also of course like Oracle database, you have asynchronous and semi-synchronous support also there in the MySQL replication. And if you look at the replication topologies, you can have multiple sources, one replica, or one source, one replica, or one source, multiple replicas. So MySQL will support a lot of replication topologies based on the customer needs. For example, if I compare, why I am comparing with Oracle, so that you will be bit understanding who are all a little bit beginners to the MySQL. In Oracle, you have a concept called real application clusters. In the sense, a two-node rack means they will have two nodes, one common storage. So these two, node 1 and node 2, it will accept the client connections. In some places I have seen one node will be for OLTP, one node will be for OLAP, or both will be taking the connections from the client. So you can make utilization of how you want based on the customer environment. But here, when I say high availability as disaster recovery, no, we don't have multiple read-write servers. So is the in RDBMS field, so only Oracle database, they have multiple nodes for taking multiple connections from the client application. But in PostgreSQL, MySQL, any other RDBMS, we don't have that flexibility. Even in MySQL's Microsoft SQL Server or IBM DB2. But whatever you have in high availability and disaster recovery scope, MySQL done a pretty decent job. That is the only reason customers like Facebook, customers like American Airlines, customers like Netflix, still they are using MySQL open source as well as some part of enterprise editions. So today we are going to show some of the scenarios in last 30 minutes. So basically, left-hand side, you have one primary and two standbys, nothing but two replicas. And the right-hand side, you have disaster recovery side. You have one primary and two standbys. So here, the left-hand side, your source cluster will completely defined or implemented on group replication. And right-hand side, if you look at disaster recovery cluster, even that is implemented on that technology like group replication. So when the transactions are coming from primary cluster, first it will go to primary database in left hand side, primary cluster. Then those transactions will go to two standbys in left hand side and three database servers on the right hand side. So if you look at any point of time, although you are able to see left hand side three servers, right hand side three servers, only one server will be able to take the client transactions. If you look at Oracle, maybe left hand side you can have multiple nodes, that to read and write. But if in a MySQL InnoDB cluster set, although I have three servers left hand side primary cluster created on group replication, right hand side I have three servers again, individual servers. Sorry. So out of six, only one primary server in primary cluster will be able to take the client connections. Remaining five servers, whether it can be a disaster recovery site, whether it's a primary cluster, everything will be in RO mode, means read-only mode. So in left-hand side, if something goes wrong for your primary cluster, one of the standby will becomes primary. And remaining five servers will be the read-only. Let's say, for example, left-hand side completely you are not able to access. Then right-hand side, your primary server will becomes primary cluster. Nothing but your one of the node will be in read-write. Remaining other two will be on read-only mode. So you keep it in mind, two things here. In MySQL InnoDB cluster, if you want to make a cluster set, I need group replication, number one. Whether you have one primary, multiple standbys at left-hand side, right-hand side, you have more than three servers. At any point of time, only one primary server will be taking the client connections. Number two, we will talk about InnoDB clusters. So what is the advantages and disadvantages going forward? So yeah, over to Phani.
Thank you, Ravi. So, hey everyone, this is Phani Kadampari. I work for InfoHub and I do have 15 years of experience as an Oracle and MySQL database admin and worked on various domains. And I do have I did my certifications in various Oracle technologies and cloud infrastructure as well as MySQL. And I'm also the technical reviewer for one of the books that is recently released, which is Mastering MySQL Administration. Today, I'll be explaining about the high availability within MySQL using the InnoDB cluster as well as the cluster set, along with the demo that will be taken here by Arun. Next slide, please. Right. So the high availability is, basically achieved, okay, by maintaining multiple redundant copies of the same data across regions or across different places, okay, within the data center. So MySQL provides a group application, which is some disturbance. Can everyone mute, please?
Yeah, please carry on. I just muted all of them. Okay.
Thank you. So MySQL provides a group application which allows the clusters to have elastic topology, wherein within the cluster we can have the servers added or released as per the application or the business needs. And it also provides high availability, wherein even if
Phani? Arun, you can take over.
Can you all hear me?
Yeah, we can hear you.
Okay, no problem.
Yeah.
Thank you. So I think looks like Phani is having an issue. Yeah, he might be joining back shortly. But until then, let us continue with the session, right? So one of the core concepts of MySQL InnoDB cluster is the group replication itself, meaning whenever we have a primary database server, right, all of the data that is in the primary database server will need to be replicated to the other DR servers as well. I know we have the normal terminology of you calling it a DR server, but in MySQL terminology, we call it a primary server and a secondary server. Okay, and usually when we are talking about a MySQL group replication, this is a highly available fault-tolerant replication topology, right? So let's say if one of our primaries goes down, one of the secondaries that we are seeing on the screen in here, right, will assume a primary role and taking over all of the functionalities of replicating it to the rest of the secondary servers. This group replication is normally offered as a plugin, and in general, we have two replication modes. One is a single primary mode, right, and the other one is a multi-primary mode. In general, within the group replication, a single primary mode with automatic primary election is used. Okay, and in order to guarantee the group membership service, right, with respect to the service availability, there is this automatic primary election. Okay, and all of the client connections that we have in here will be redirected or failed over to the as soon as the primary. And one limitation here with respect to group replication, right? You guys might ask, you know, why do we have to use InnoDB cluster when we already have MySQL group replication available in here, right? The most, if you look at it from a customer standpoint, right? At the end of the day, the reason we have this solution is because is to actually have is to actually make the database available to, excuse me, available to them. So what happens is, as long as the connections are automatically failed over, right? Meaning as an end user, as a client or an application, if I'm able to transparently fail over to the other primary without seeing an impact, and all of this action is happening in the background, that's what the actual high availability definition is. And one limitation here with MySQL group replication is it won't actually redirect all of the connections to this new primary. For example, in this diagram in here on the left, so there is one primary and one secondary and the other secondary, right? Let's say the primary went down and this secondary in here, wherein I'm hovering over to go to assume the primary role. Okay, so what will happen is all of the connections that are in here, right? Even though this becomes a primary, as a client, I still need to update my configuration to point to this secondary. So that's the limitation. There is still some amount of manual intervention that is required when you're talking about a group replication. Okay? So that's the limitation, and that's the reason by adding additional components to this group replication, like MySQL router, MySQL shell, and all of this, the InnoDB cluster has been formed to provide this automatic features and make it transparent to the application or the end user. Next slide, please. Okay, and that's where the InnoDB cluster thing, right? If you look at it, there is this MySQL router that you're seeing in here, the MySQL shell. These are the additional components that they have basically added to kind of form an InnoDB cluster. And that's why
Arun,
the key components.
sorry to interrupt you.
Yes.
Your voice is too low. Can you please check your mic? Okay.
Okay, one moment. How about now? Any better?
Yeah, it's very good. Go ahead.
Okay, all right. Sorry about that. Yeah, coming back to this, all of these different components are actually formed the key components of this InnoDB cluster, and that's the reason the InnoDB cluster has come into the mix in here, right? Wherein it provides a completely highly available and a scalable solution. Okay, and when you're talking about the MySQL group replication, right? These are the different things. What it does, we just looked at it on what the MySQL group replication does to us. And then we have the MySQL shell. Again, in order to maintain and administer all of this cluster, we need to have some sort of a shell, right? To be able to talk to the InnoDB cluster itself. And that's where the MySQL shell comes into the mix, wherein it is an advanced client and code editor. By default, it will default to a JavaScript notion, which we will shortly see in our demo as well. But in addition, let's say if you are comfortable with Python, right, you could still use Python. And on top of it, if at all you wanted to run any SQL commands to interact with the InnoDB cluster, you could still use MySQL shell as well for it. And that's where there is this API that is called the MySQL Admin API, which is installed along with MySQL Shell. And MySQL Shell uses that MySQL Admin API to interact with the InnoDB cluster. And then we have this router. Of course, we talked about the limitation of the group replication itself, right? Wherein it does not have automatic router capabilities. That's where the MySQL router will come into the mix to basically provide a transparent client connection routing between the application and the cluster. Meaning, so as soon as the primary goes down, the secondary automatically assumes the primary role. That's the function of the group replication itself. And what router does is all the connections that are still coming in from the application side, it would automatically reroute to secondary without us as a client or an application team doesn't have to make any changes. Okay. Next slide, please. I see Phani joined back. Phani, can you confirm you are able to join back?
You go ahead, Arun.
Okay.
Flow willingness. You go ahead.
Sure, no problem. So, and coming back to the InnoDB cluster architecture, right? So just like we looked at it, it basically relies completely on the MySQL group replication architecture, right? And since it is offered as a plugin, each of this plugin will need to be installed on every MySQL server within the InnoDB cluster itself. And if you looked at the previous slide, if you recall the previous slide, we do have 3 MySQL servers that are in place, and that MySQL group replication plugin will be installed on each one of those 3. And the main functionality of group replication is to basically create those elastic configurations depending on our application use cases, right? Like Ravi sir shared earlier in the presentation, you did see different replication topologies, right? You can basically use these replication topologies to kind of create a source and the replica configuration, source to multiple replica configuration, right? And it all depends on your application use cases. For example, if at all you have to perform a read scale out, you would want more number of replica servers being created. So you can have those specific clients connecting to that secondary replica to perform all of your read and analytical sort of workloads. Right? And the InnoDB cluster architecture requires, it says that there should be a minimum of 3 servers within the cluster itself. Right? And the reason for that is, in order to provide a highly available configuration within the region, right, within the data center, you need to have at least a minimum of 3 servers. This is a similar concept wherein you would see with other Oracle databases as well, wherein it has a similar requirement to be able to form a quorum. And like we discussed, there are two different modes. One is a single primary mode or a multi-primary mode, correct? And then whatever the plugin that we are using, right? This group replication plugin was first introduced in 5.7, okay? And to be able to work with it with the group replication, it is normally tricky, and that's where the InnoDB cluster kind of came in with a combination of MySQL router, shell, and connector. All of these other components are tightly coupled to make it easier for us to basically set up a database store, right? Next slide, please. Yeah, we just talked about the group replication plugin in the previous one, right? So basically, to summarize, what it does is it automatically handles a server failover type of situations, right? And whenever a server is down, and let's say the server is back up, it would automatically join the cluster as well without us having to enter them. And the fault tolerance and all of the conflict resolution is already built in into the plugin itself. And it maintains a fully highly available and a replicated database at all times. Just a quick sound check. Are you able to hear me okay, or should I speak a little bit loud?
No, it's okay. It's okay.
Okay, thank you. And how does the group replication work, right? In general, in group replication, what we do is we normally form a replication group, and each replication group can contain up to 9 servers, right? And like we discussed, at least there are 3 servers that are required for a group replication group to be fault tolerant, okay? And the replication type that we use here is the GTID based replication, which we refer to as global transaction identifier replication. And there are other types of replication too, but for the InnoDB replication to work, we will need to make sure we use the global transaction identifier based replication. Okay, and also the group membership is managed automatically, meaning whenever a server goes offline or comes back online, it would automatically get removed from the cluster and added back into the cluster transparently without the end user having to take any action. And we spoke about the 2 modes, single primary and the multi-primary. And all of the changes, any changes that are made to the primary will get replicated to all the secondaries that are out there. Next slide, please. And these are the requirements that you would see, right? Of course, for communication, group replication normally works. It's recommended to use it within the data center or within the region itself, wherein you need local network to basically reduce latency, right? And these are one of the most common situations, especially when you're architecting for a InnoDB cluster. You got to make sure they are in close proximity to reduce that latency. Else you would run into situations like network partition situations and all of it, wherein the server joins and leaves the cluster in and out. And also for the conflict detection, right? The requirement is to use InnoDB storage engines. There are other storage engines that are available within MySQL as well, depending on how you wanted to use it. But for group replication, the InnoDB storage engine should be used because it provides the extreme data consistency that we are looking for. And every table that we have within the database will need to have a primary key. And the GTID, the global transaction IDs need to be enabled, and those act as the transaction identifiers as part of the replication topology. And in addition to it, we need to make sure the binary logging and the slave updates are enabled, and also the binary log row format. Metadata must be stored in a table format, and these are the other requirements that you would consider for replication. Next. Yeah, like we discussed, MySQL shell, it is an advanced client code parameter. We do have JavaScript, Python, and everything. And these are some of the commands that you could basically use to interact with the InnoDB cluster itself, right? Let's say if you hit /py, it takes you into a Python code editor. If you say /js, it takes into a JavaScript editor. Okay. And when you're talking about the MySQL features of our APIs, these are called XDev APIs and admin APIs. And like we have seen, admin API is what we as database administrators or database architects would use to basically configure and administer the InnoDB cluster itself. And with respect to talking about, MySQL supports the document store capability as well. If at all you wanted to use MySQL as a document store, XDev API is the other API that you would need to install to make sure you're interacting with the MySQL document store. And like we said, it supports both the table format and also the JSON formats. And depending on your application use case, you basically configure it from there. And the setup and the installation of MySQL shell is pretty straightforward. You could just download the binary and just perform a yum install of the binary from the software binaries that are out there. Next slide, please. And MySQL router. MySQL router is one of the most important components of it. At the end of the day, the MySQL router is what will transparently maintain the routing between the client applications and the backend MySQL servers, right? If at all your application should not see any impact, where in order to maintain those high SLAs that your application have, MySQL router is the one that maintains all of it. So it is very important to have a highly available configuration for your MySQL router as well, wherein all of the configuration and the control on how the client connections are redirected will be managed as part of it. Okay. And automatically routing connections, that's quite evident in the architectural diagram that we have seen earlier as well. And in addition, one of the key capabilities that it provides is also the load balancing capabilities. And the router is always aware of how a server is, how much load a server is basically taking, and it automatically, directs all of those connections based on the load at that time on that server. And you can always customize the loads as well. For example, if you wanted to put 70% load on one region and 30% load on other region, you can always control it through MySQL configuration as well. There are several parameters, and this concept in itself, calls for another session wherein you'll be able to look at all of those parameters very closely. And again, it's a pluggable architecture, and you could basically deploy, configure changes, make any of these changes to the configuration file on the thing. And one of the things that I wanted to call out is the new feature that it was introduced in MySQL Router version 8.2. That is actually called the transparent read rate splitting. Right? Depending on the nature of the queries that we are writing to the database. For example, if you are writing select queries, right? Since it is a type of a read type of a query, the router will automatically know this is a select query and this is for reading data. So it will automatically direct that query to the secondary servers that are in the cluster. And if at all you are putting in a insert sort of a statement wherein you'll have to write data into the database, right? That will get directed to the primary server, depending on how it is. And again, this can be downloaded and installed. Installation is pretty straightforward. Just will have to go through. Imagine, I know most of you guys are come from an Oracle background as well. Imagine setting up a rack. What are the complexity that we'll have to go through versus how easily we can basically set up a MySQL cluster. Right, please. Yeah, I think just so I know, I would have started off with introducing myself, but again, I was just waiting for it. We'll skip this, and my author bio is on the presentation as well. We'll come back and talk through it. Next slide, please. And coming back to here, right, the InnoDB cluster creation. Like I said, in order to create a cluster, we don't have to go through a very complex setup like we normally do in an Oracle database or, as a matter of fact, any other database engine, right? One of the things that MySQL, I like about MySQL is the ease of setup and configuration of things, right? Excuse me. Especially with running enterprise grade applications, right? And if you are able to administer it easily, right, that is very helpful. And that's where MySQL InnoDB classification. And just with these basic 5 steps that you're seeing on the screen right here, right, you can create an InnoDB cluster and start running with it. Okay. And of course, there are some prerequisites that you'll have to take care. Like creating a cluster admin user, making sure the networking is in place, the installations and everything, which we will basically look through it. And one of the most important things as part of this thing is, if you look at the very first command, the pre-check instance configuration. You have an existing server and you wanted to check if that server can be part of an InnoDB cluster, right? What you normally do is, after installing the MySQL shell and creating the cluster admin user, what you could basically do is you could run this dba.checkinstance configuration command, and it will tell you whether your MySQL server is ready to be part of an InnoDB cluster usage, right? And it will generate a quick report for us to look at, and it will also ask whether you wanted to change whether it can change the parameters for us, or do we want to change it manually as well. Let's say if you say, you go ahead and change it for me, and it would do it for us and keep it ready for the InnoDB cluster usage. Next slide, please. And once we set up a basic cluster, right, we will see this shortly as well. As a precursor to it, I wanted to quickly touch upon a few important ones in here. If you once an InnoDB cluster is basically set up, if you run the cluster.status command, what this is telling me is I have named my cluster as my primary cluster, okay, and my primary is MySQL A. And the port that it is listing is the default port, which is 3306. And if you look at the member role and the mode, of course, the member role is primary, and it will be in a read-write mode. And that's what it is basically telling us. And MySQL B is in a secondary role, and the mode is read-only. And similarly, MySQL C is also in a secondary role, and also the mode is read-only for that specific server. And if we also look at the topology mode, right now the demo setup that we have is a single primary mode. And if at all you wanted to kind of talk about a multi-primary mode into an active type of a setup, that's where you kind of deploy the InnoDB cluster as multi-primary mode. Next slide, please. Yeah, we have seen the high-level overview about the InnoDB cluster, right? The reason this slide is here again is because the InnoDB, right? What we wanted to see here is the primary cluster. Here you would see A, B, and C, right, in the primary cluster, and D, E, and F is on the DR cluster that is out there. And we'll have basically 2 routers, and the client connections and everything would be there. And the data is replicated asynchronously from the primary cluster to the DR cluster. So Ravi sir briefly covered early in this presentation. Now, this is the demo environment we currently have. So what we will, next slide, please. And of course, to cluster set, similar set of commands that we use. Which you could, we will set the presentation over, so you have these with you as well. Next slide, please. And of course, these are some of the configuration options and everything. We did talk about what are all that are required, right, with respect to group replication and everything, and the functionality the InnoDB cluster set provides, right? Next slide. And the cluster usage, right? These are all the different cluster set creation commands, how to basically create a replica cluster and everything. These are the different commands you would use it. Next slide. This is how we check cluster set status, just like we are doing the InnoDB cluster, right? Here it is saying my primary cluster. And within that primary cluster, MySQL A is my primary. And then I have a replica cluster called my DR cluster, I called it, right? And it says the status is healthy, what's my primary cluster, and what is the global primary instance. Since we said that is key, because since we said global primary instance, it is basically one single primary that is accepting all of the read-write connections. Next slide, please. these are the steps that you would basically use to set up a MySQL router. It calls for a MySQL router admin account, right? An OS user, and you would basically perform a bootstrap so that the MySQL router knows the cluster configuration and it automatically detects all of it. And if you want to configure high availability for your routers, you could also do that, and that's where you would maintain and manage using the cluster.list routers. Next slide, please. Yeah. Having said that, let's switch to the demo side of things.
So,
And within demo,
yeah, Arun, I will stop sharing. You share your screen.
yeah, there are some more slides on it that quickly I wanted to cover.
Okay, got it.
Yeah, I will switch. Yeah, I can start sharing on my end. Probably I can switch if that's okay.
Yeah, go ahead, Arun. I will stop sharing.
Thank you. Let me know when you are able to see my screen. Are you able to see my screen?
Yeah. Good, Arun. Go ahead.
Yeah. And there are a few scenarios that we will basically look through, right? The very first scenario that we would be doing is, if you look at it, we actually perform a switchover. This is the most common scenario in a real world that we would basically use, right? You're performing a maintenance on your primary cluster. You have to make sure your application still works as expected. Nothing major needs to happen to the application. What you would do, you would basically initiate a switchover, right? This is mostly in terms of planned maintenance, right? You're performing upgrades, you're performing some sort of maintenance on the primary side. You use this use case basically, right? Let's quickly look at how to perform that switchover, okay? So within here, right, all the top tabs that you're seeing in green, for example, A, B, C are part of the primary cluster, and D, E, and F are part of my replica cluster, okay? So I colored it so that you would be able to see this. So one of the things that you would basically see is first check MySQL D is running on all, right? So if you run this command on all of the servers, MySQL D, you will basically see that MySQL D would be running as expected. And like I said, I actually created, there is MySQL shell that is already installed on each one of these things. And the way I connect to MySQL shell is I use the binary called MySQL sh, right? And as a prerequisite, you'll have to set up to administer the cluster itself, you'll have to basically set up this OS user, which is called MySQL cluster admin, right? And let me log in using that. If you see by default, it is defaulting to the JavaScript side of things. And let's say if you wanted to switch to a Python, you would basically run /py and it would take into a Python editor. I'm quite familiar and comfortable with using JavaScript, so I just left it to the default one in here. Okay. So before that, the way we can basically show it, you can basically check the configuration. So let's check how our cluster set configuration is. So what you would basically do here is you would start setting a variable called MySQL cluster set, and within to that variable, we are basically using the Java method saying dba.getClusterSet. This method will basically get the current status of the cluster set itself. Okay. Once we set that variable, you use that method to check the status. So for example, if you do cluster set get status, and this is the command that we saw on the slide, right? And here what it is saying is, I do have two clusters within my cluster set. One is a primary cluster and the other one is a replica cluster. My primary cluster is named as my primary cluster, and my secondary replica cluster is named as my DR cluster, right? So that's what we are working on. And it says the cluster set status is healthy and all clusters within my cluster set are basically available. Meaning right now, both my primary region and my DR region is up and running as expected without any issues. That's what this is saying here. And if you want to look at a detailed status, we have something called extended one that you could basically use. This will give you all the detailed information about every server that is with part of the cluster set configuration. And if you see the transaction set, this is the GTID, right? And this is the GTID identifier, and these are the transaction IDs that it is basically looking for. And that's what they are replicating from primary to the DR side, right? This is what the cluster set is looking for. And to basically perform a switchover, right? So what we will do is there is this command called, let me use, I wanted to tail the MySQL D log as well. So you see what sort of changes are happening in the background. Okay, the bottom part is the MySQL D log for the primary server. And before you're doing the switchover, right? So what you can basically do is you can basically do the dry run, right? So just to make sure everything will work as expected, right? Just to check even before initiating the actual switchover, you can always perform a dry run. So this is the command that we use. What you are saying is within my cluster set called my cluster set, I wanted to set my primary cluster, my DR cluster, which is my replica cluster, as the primary cluster, and I wanted to perform a dry run on it. That's what I'm telling using this command. So once you start issuing this, let's see what happens, right? It says the dry run is enabled and no changes will be made, right? What it would do in the backend is it will run. I will look for the cluster set status, making sure everything is, all the clusters within the cluster set are healthy and available. That's what it is doing in here. Then whatever since we are wanting to promote my DR cluster as a new primary cluster, right? It would check for any pending transactions that it needs to apply before issuing the switchover. And it would automatically update the metadata. There are some InnoDB specific metadata tables that are in place that it would use. And also with respect to the topology that we'll have, it always keeps track of it, right? Now that we verified the replica cluster can be made primary without any issues, we can go ahead and issue the actual switchover command, right? And all I'm saying is set my replica cluster as primary cluster just with this method. See, it is automatically loaded. In reality, let's say if you have more data within your database and everything, as long as both the primary cluster and the DR cluster are in sync, they should be this quick. Okay. And if you look at some of these things, right? If you look at some of the things, right, these are the things. If you see what happened in the backend was, it is saying replica receiver channel, right? And here you will see, and if you see, this is the command it is running in the backend. Change replication source for channel cluster replication executed, right? And it is saying MySQL D because that's my primary within the DR cluster, right? And it is changing to all of these things. And that's how it maintains this thing. So now if you want to check the cluster status, the command we issue here is cluster set status. Now if you see in here, my primary cluster's role is replica, and my DR cluster role is primary. And my new primary in here is MySQL D, not MySQL A. Right? that kind of confirms that we perform the switchover successfully, meaning our DR region is active now. And let's say if you want to switch back, right? So what you would simply do is come back and issue the same command. This time, since you wanted to make your primary cluster as the new primary, you come back and issue the command in here. So just like that has happened, now it would run a new command in the backend to make sure the primary instance in here. And if you run the status again, right now, if you see that our new primary cluster is primary and our replicas. So you can basically, what we just did was we performed a switchover and switch back to our primary. Okay. So the next use case within our demo is, right, within the primary cluster, let's see what happens, right? Let's say all of a sudden our whichever is our single primary, something happened with issue, the server crashed, right? Let's observe what will happen, right? In general, what it should happen is there should be another selection that needs to happen, wherein in this case, we can say MySQL B will become the new primary, and all of the client connections will get directed to new primary. Since the server crashed, what will happen is there are only 2 servers within our primary group, and it would say, let's say if another failure happens, it will basically tell us, I cannot provide high availability within the region. You have to have, since we looked at it, since we need to have minimum of 3 servers in order to maintain a highly available configuration, we have to look at recreating those servers or restoring it from backup and trying to make sure it joins back this cluster, right? Those are the other operations that we need to do. So let's see what happens, right? So to basically get out of this editor, you just to still open. Logging into B. Okay. So I logged into B. So if you check the current status in here, right? Okay. I'm creating a variable in here. I would say cluster.status. When you run cluster.status, it would just give us the status of this primary cluster in here. And what we are wanting to do here is we wanted to take A down, right? So let me go in. I have my VMs running. What I'm doing here, I'm just crashing my MySQL A. Okay, I'll just power it down, simulating a situation, failover type of situation. Let's see what happens in the background. And if you see in here, it's what does it say? Just look at the timestamp too. New primary member GTID is executed. Elected primary member. A new primary with address MySQL B was elected, right? So So what exactly happened here was, now that this is offline, the MySQL B assumed the new primary role. So if you see, this is actually automatically done in the backend. We didn't make any changes, or we did not say make primary MySQL B as the primary, right? It automatically happened for us. So now let's see what happens if we turn on our server went offline. For some reason, it rebooted. It came back online. Let's see what happens. I'm turning my server back on. As soon as it detects that the server is back up, we should see some changes in here, wherein it is automatically adding that server back into the cluster configuration as a secondary. Since B is already chosen as the primary one, this would automatically come back and join the cluster. As soon as it detected MySQL A is up and running, it is updating all of the metadata, and it is saying still my seed joined as the secondary, and it updated the cluster configuration. So now if we go back and issue the, right, this is previous, right, previous status. There it was primary as MySQL A. Now if we run the cluster.status command again, okay, it says you have to basically disconnect. Let me log in again. Okay, to see cluster.status. You see here, now MySQL B is the new primary and MySQL A is in a secondary role. What just simply happened was it failed. It come back and joined the cluster automatically. But still, since B assumed the primary role, it will continue to do so. But after some time, based on your requirements, you just wanted to keep MySQL A as your primary, right? How do you do this? What you could do is simply say, within my cluster, I wanted my primary instance to be A, right? You'll come back and say, set primary instance as MySQL A. Okay. It says MySQL C is remaining a secondary. B became a secondary now, and A became the new primary. And if you issue the status, now MySQL A is the new primary. What we basically did was, instead of doing a regional switchover, we just did a switchover within the, we did switchover between A and B. That's it, right? On the original, what this is doing is, let's say you're doing some maintenance in A, you could use this use case to basically cover that. So with that, the demo is complete.
Yeah, thank you, Arun. If any queries, please go ahead. Maybe one by one. If you have any queries, please go one by one.
I think, Ravi, there are some questions in the Q&A, right? So they all are addressed in the chart.
Let me check.
Yeah, I think Phani has addressed. Okay. Okay.
I do have some questions. If allows, I will raise it.
Please go ahead. Mohammed Bhai, please go ahead.
Yes. See, the first question is, as you said, this group is there, one primary and two secondary. And then there is a DR cluster is there. Two clusters are there like that. And the switchover and failover is happening between them. Is it possible without the second cluster, if the same primary we will keep on the main site and the secondary, one of the secondary will keep on the DR side? So is it possible, or it has to have a cluster, complete cluster itself on the DR side?
Yeah, let me understand your question, Mohammed. So what you're saying is this is the setup that you're talking about.
Yeah. Here you
And
have
you're
here,
saying
yeah, here you have the DR cluster is there. The complete three machines are there on the
correct,
DR side.
correct,
So
correct.
instead of that complete setup, if we extend the same one of the secondary in the primary cluster side to the DR side,
Mhm. So you're
so
saying
that,
instead of having 3 servers, if I have just 1 server, can I do that?
yeah, instead of also it should not be a cluster. It should be like connecting to the main primary.
Got
The
it.
two,
Mhm.
yeah, the primary cluster, you have two secondaries, right? So one secondary, if you can
Correct.
keep it on the one secondary, or say both the
DR side.
secondaries, yeah, is it possible?
You can do that. Yes, that is possible. The only downside to it I see is, right, usually the whole purpose of providing this configuration is to basically have a highly available and DR configuration, right? So in order to maintain a highly available configuration within the region, usually regions are, for example, we have um, um, I mean, I'm just using the US geography as an example, right? So I have one in the US East region and I have one in the US West region. So the distance between is so huge, right? But for you to actually take one secondary replica and put it in the other region, there is a lot of network latency in between, which you'll have to account for, right? So as long as your network is stable enough and you have enough bandwidth to kind of sustain and maintain the cluster configuration, that's a possibility. Technically, it is possible. Practically, whether it is feasible or not depends on other parameters. Okay. What you could do instead is, if at all you wanted to minimize some of these things, is you can say which is your primary region, right? You can always maintain this InnoDB cluster, and within the DR cluster, instead of having 3, maybe you could start with having 1, right? If it is if your solution is getting expensive or because of some other reasons, you what that means is, let's say your something happened in region 1, right? So this basically failed. The entire region is done, some because of some natural disaster or some power failure or something, right? When you switch over your application to the DR site, you only have one server, and if you look at the load of this, right, that one server should be able to handle all of that load in that situation. So those are some
So
of
you mean
the.
you mean you
Go
mean
ahead.
sorry, you mean the secondary, the one primary and other two secondary. So is it load balancing
Mhm.
also amongst them? Because these are
Yes,
not active. I believe these are not active, right? So load balancing
correct.
is
And
not a.
that's what they. Yes. So the load balancing is done by the router, and that's what one of the router features is.
Load balancing in this case, I think it is when it will be switched to the secondary, from primary to secondary,
Mhm.
then only
Mhm.
the load balancer will come into picture. It is not, primary and secondary are not active at the same time, right?
They are not active at the same time, correct?
So traffic load balancing is just on traffic is only on one node only.
That is correct. On one region only,
Yeah,
one
under one
cluster
region,
only.
the traffic is going to one node at a time. When it will fail over, then it will go to the other node, but it is only to the one node. Actively, it is going
That
to
is
one
correct.
node
But
only.
it is
Yes.
to one. So what I'm trying to tell you is, for example, you have an application workload. Right now, it is all distributed across 3 nodes. When you perform that switchover in that type of situation, you will only have one node. Correct. You're right. So what that means is, right, you got to make sure in your architecture consideration, this one single server in your DR side should be able to handle all of that workload, application workload.
And in case of switch over to DR, the application
Mhm.
connections will automatically rotate, or the DR, or
Yes. And that's part of the router configuration that you define.
okay. What is the maximum latency we should consider while configuring this?
Usually,
Acceptable latency, I mean,
yeah.
between the primary and the DR cluster.
Yeah, I mean, since it is asynchronous replication in this type of things, usually a bit of latency is fine as long as it catches up eventually. But within the region, it is always recommended to keep less than 5 milliseconds.
Less than 5 milliseconds, it should be.
Correct.
And is it full database replication like in case of data guard in Oracle? It is completely based
Mhm.
on the log switches, redo log switches and all.
Mhm. Mhm.
So
Mhm.
log
Yeah,
transfer is there.
here it is.
Here,
Correct. Mm.
here it is on the table level and SQL level, or how it is like?
Right. Here also it is, if you look at it, it's GTID based replication, right? And the GTID based replication is based on the binary logs themselves, which is similar to the redo log switches that are happening on the Oracle side. If more and more activity is happening, all of those performance related factors need to be factored in and considered.
Like in Oracle, we have option that all the addition of table spaces, data files done on the primary side
Correct.
will
Right. Yeah.
automatically get replicated here also. So same options are available here also.
Similar options. I'm not saying same options. Similar options from a
Similar
performance
options.
standpoint. You'll have to factor. Yeah.
And how about the licensing cost and
Any,
all?
sure. Any DB engine replication topology you consider, the underneath concepts are pretty much the same, right?
Okay,
Except every engine does it in a different way and they have a different name. Yeah. With respect to the cost, I would say, reach out to your local Oracle team. It'll all depend upon your region specific cost and other factors that are in
No,
there.
that is okay. That is okay. But is it similar to like open source databases like
I see
Maria
what you're
and
saying. Okay. Sure.
Maria and
Yeah.
Postgres?
So
So it falls
the
under those category, or it is a traditional database category like Oracle,
yeah.
SQL, Microsoft SQL.
So mhm, mhm. So let me clarify that, right? So you have two options. Either you can go with an open source version of Oracle MySQL or an enterprise edition of Oracle MySQL. The thing with Oracle Enterprise Edition of MySQL is features like InnoDB cluster, enterprise backup, enterprise monitor. Those are some of the other features you get when you're using it, right? But within open source, you get standard, source replication only, meaning you have one server and you can only configure the other server. You won't actually get the enterprise version of it. It's
Is
not
DR
available in the open source version of it.
so DR cluster cannot be configured in the open source.
Correct. Not even, and also this one also.
Only
Not even
one
this InnoDB
secondary. Yeah.
cluster as well.
Okay.
Right.
Does it require to have a thorough knowledge of Java programming, or simple commands knowledge is
Not
enough?
required.
Okay.
Simple command knowledge is enough. I'm not a Java expert either. I was just able to follow the documentation and just use those basic commands to create and manage this. I mean,
So
at
being
least
a
based on my experience, I haven't actually used Java extensively to be able to administer and do all of this.
Oracle DBA, we can put our fingers on that side. Not an issue. Huh?
Oh, absolutely. It's pretty easy when compared to Oracle. I've been in Oracle DBA myself for several number of years. So when we set up MySQL for some of our applications, I felt it's pretty straightforward and easy to set up and work with.
Okay.
Yeah, definitely. I think, like Ravi sir mentioned earlier, right? This is one of the leading open source things that we have, basically.
Also,
We have other open source options too, but again, this is one of good options that you could definitely consider.
is any I mean industries are prefer to have mission critical databases on MySQL?
It's not a requirement, right? It's a company's choice
No,
and general.
means
But if you look at Muhammad Bhai, if you look at American Airlines is one of the leading airlines, like Qatar and Emirates. Like that, we have American Airlines in the United States. So they were using MySQL and Facebook. You know how people are load videos and JPEGs, pictures, messages. So completely Facebook runs on MySQL 5.7. The two open source, not enterprise edition. So some part LinkedIn, some part Netflix. So predominantly, this also one of the mostly used open source.
okay.
But it depends on the BFS, let's say banking, financial customers. No, always they look at atomicity or consistency, concurrency. They look at Oracle, but these also even Postgres and MySQL also will fall under RDBMS, and they are widely using. I said no, Facebook, American Airlines, some part of Netflix and LinkedIn, and some part of Uber. So these are all the big accounts. These are not a small accounts, well-known accounts, right?
Yeah, those are the industries which you showed here are definitely very high-level
Yeah.
industries. But the database for which they are using is it a really critical database or it's big critical
For
but
ex
small? Yeah.
yeah, for example, you take it Facebook. Maybe you heard last 10 years, 1 or 2 times, or maybe less than 10 times downtime. Maybe,
Okay. Facebook is using MySQL, you mean?
no doubt. Yeah, MySQL only. MySQL
Okay.
only. Complete open source. So maybe
Oh,
last 10 years, maybe I heard five times no, downtime.
uh,
Not more than that, I believe.
okay.
Yeah,
Thanks. Thank you so much.
no problem, sir. You're welcome.
Really very useful info.
Yeah. So, any queries? Any queries? Even we are available. You can check with Basha, our mail IDs, and you can go to LinkedIn and you can connect with us also. So we are very happy to share our experiences. Arun, can you go to our last slide so that people will know if any queries or if any support, or even we can learn from you if your environment is different than us. No, we will try to learn even your environment. So thanks again for Nashyam Basha for giving this opportunity, and thanks to Arun Samayam and Phani, and thanks to all in Saturday. You are able to no, come to this session. More than 20 people means we are very happy because it's a weekend, and in long weekend in the United States also. So this we are talking about. Last week only this book released. This book completely deals with a step-by-step document, step by step. Even chapter number 6 and chapter number 7 and chapter number 12. So these are the chapters. Even now, you don't find good documentation to Oracle. So we released this book in MySQL Summit in Oracle headquarters. So I will mention chapter 6 and chapter 7 and the chapter 12 and 13. These are the chapters even you cannot find the documentation in MySQL. So basically, this book is written by myself and Arun Samayam from American Airlines, one more author, Naresh Kumar from Facebook. What we did is we have taken all the customer use cases. We have taken all the customer use cases and we ported into this book. So this book talks about a completely hands-on InnoDB cluster, NDB cluster, enterprise backup, how to monitor through OEM 13C cloud control and enterprise monitor. So it will talk about even open source and enterprise concepts. So if you have time and you can look at it, this book, if it is feasible to you, your
Ravi,
environment. Yeah.
we have to ask attendees, how many of them are MySQL DBAs? If so, You can ask a random quiz question, and the winner maybe we can give him this book as a gift. Okay,
Yeah,
maybe.
sure. Arun, you can go ahead. Poll one question. If no, one right answer, first in, first out, so we can send that book to their home address. Yeah.
Before that, can I please have one question? Is it
Yeah.
possible to use this technology along with DB2 of replication?
You are talking about IBM DB2?
Yes, yes. Can we use this replication technology of primary cluster and DR cluster?
I don't
Not
think so.
using the
Yeah.
not using the Oracle MySQL technologies, right? But you'll have to use third-party tools
Okay, okay.
to be able to replicate from MySQL to other things. Yeah, this is purely showing the replication topologies using MySQL technologies only.
It is binded up with MySQL only. We cannot use this replication as a third-party tool for other database like Microsoft SQL or DB2.
Yes,
Okay.
that's correct.
Thank you. Thanks.
Yeah,
Yeah,
no
go
problem.
ahead. One query, Arun. Maybe based on our slides only. Maybe how many people have concentrated. We can see, and we will see. Yeah.
Sure.
It should be very tough question, right, Arun?
Yeah, we'll make it easy. Yeah, don't worry. So
Sure, I will not purchase them.
I'll. So right. Let's say within our primary cluster, right? We have 3 servers, right? A, B, and C. As part of my MySQL configuration file, I've assigned server ID as 1 to MySQL A, server ID as 1 to MySQL B, and server ID as 3 to MySQL C. Right? So is that a valid configuration?
No, it's not valid.
If okay. Why?
Hello?
Can you say why?
Yeah, actually, as part of replication, we have to use different server IDs, and only it will. That is the correct configuration. Because if we use the same, it can't identify the which one we need to connect, na.
Yes, you're right. Unique ID should be used. Perfect. Who answered this? Sorry.
Satish Kumar.
Yeah. Okay.
Thank you.
Satish, let's message your let me message with your WhatsApp number. Okay, I will contact you. Okay, thanks.
Yeah, I will update my WhatsApp number in the chat. Can I update?
Sure.
Okay.
Yeah, just send me my mobile number to you. You can contact me. Thanks. Yeah, I think excellent session though, right? Many questions we observed from attendees. That's the very good part, right? And the 1 hour session extended to 1 hour 20 minutes. That way we can understand how session is interactive, right? Yeah. Thank you.
No, thank you so much for the opportunity, KSAOUG, especially Asim sir and Zahir sir for organizing this for us. And like Ravi sir mentioned, it's a great turnaround on a Saturday evening for us. Now, thank you so much. And thanks to both Ravi sir and Phani for partnering today to do this. And if you need a deep dive on any other topics, please do let us know. We will continue to work with you to kind of share these webinars for you.
Okay.
Yeah. Thank you,
Thank you.
everyone.